studied architecture in the UK and interior design, and I'm currently working with an American company that has a UK base, and they work in healthcare, sports, hospitality, and master planning. So within this project, I was based on the design team, which allowed us to sort of plug into the different sectors. So the client was in Egypt. I don't know if you guys are aware, Egypt's city, Cairo, is moving to a different side outside of Egypt. And this is their development for a medical city, which would incorporate everything from antenatal, cardiac arrest. I'm not necessarily versed in all the areas of medicine, but they have key specialist programs as well as rehabilitation. So we had a couple of buildings within the master plan that we caveated as phase A, and then we had to do the design development for it and work forward. So initially we had the rehabilitation center, the University General Hospital and the Doctors Plaza, with a critical command building after. As we focused on the Doctors Plaza, the idea was to take an initial grid, which would be 10 meters by 9, and start working on the modular facade. And if it worked on the smaller grid, you can then replicate it across the rest of the facade. So with that being the case, before we got to this point, I think this was workshop 4. So we had gone through over 100 iterations on what kind of facade typologies would be based on the skin of this building. So based on the terracotta system in the city center, a single repeatable thin vertical element would be added to the facade. The maintenance walkway would provide adequate shading while reducing the facade depth. Now, because of the rotation of the buildings, the way you treat the facade has to be different in every way to make sure that you get in enough sunlight, and also the patients and the clients that will be using the building are comfortable and they're receiving their level of sunlight. So we then, through scripting, solar analysis, took one of the wardrooms and started working through what the spatial daylight analysis through the year would be according to the lux levels. So if we had a facade that had the whole of the building open, or the spaces open, there'd be too much light and the comfort to the patient would not work. So we then said, in the UK, there is a LEED requirement which certifies your building to be to use all the sort of light levels and sustainability initiatives to make it a better building. So based on that, our initial baseline treated the buildings with no minimum shading, and the occupied zone would be greater than 45%. Knowing that the exterior shading will be incorporated in future design, iterations to reduce the daylight, the standard sun analysis would have been chosen to have a window to wall ratio of 60%. We then looked at the annual sunlight exposure to also see how this affected us. So we also then concluded that if the area receives at least 1,000 lux for at least 250 people a year for the baseline treated, then no shading would be needed, but all instances over the 10% target of the LEED compliance, for this we deduced that the shading elements were actually necessary, and as we move on to the following pages, we'll just sort of break down the stats. The impact of peak cooling and initial cost and sizing of the terminal air units within the thermal zone created a central cooling plant, but the glazing area has a large impact on the peak cooling loads in the climate of Cairo, and particularly on the southern facades. So with this, the percentage increase of the annual energy cost is not as great as the peak cooling load. The peak cooling load increases because energy is consumed throughout the year rather than looking at one moment in time. We then modeled one of the units and started then looking at what a 60% facade with no shading would look like in the winter months of October with a February low angle sun from about 10 a.m. to 3 p.m. So in terms of the solar glare, this is not a room that is healthy for a patient. We then started breaking it down in an area of 60 to 35%, and then looked at the December months. We then started looking at, with the information deduced from the climate analysis, we then started saying, okay, if the glazing reduced 60% in line with the solar study, then we would need to implement horizontal elements of at least 2 meters 750 with a window height of, within the window heights having single panel spandrels. So you have the heavier vertical channels, you have the thinner channels in between, and then even if the floor space, the finished floor level is lower, we increase the fin to make sure that your lighting and your shading sort of hits that base and takes off a percentage of the solar glare. And this is the development of adding the thinner spandrels to make sure that we are meeting the ratio of sunlight within the building. We then had to describe this to the client as a sectional facade, a sectional detail to sort of explain that. So these are the vertical fins. You can see where the sunlight clashes. Your finished floor to ceiling is 2 meters 750, and obviously dependent on the floor, because some of our floors were different, you would then adjust this base panel to take into consideration what the heights were. We then started explaining what the views out from the facade would be. So you would have your concrete GRC primary grid. You would then impact this with a level of carving and design that would be tempered to the local community, because studies have found that the more connected you are to your building, whether it's by how we treat the interior, how we furnish everything, the wellness or the speed and recovery that your patients will be increased. So we had the interior design team, which was based in DC, go through a color palette and interior mood boards to sort of incorporate that. So the planting that we were using was local to the community, and in the later pages I'll show you that development. So again, with every facade that we designed, we tested it against every single piece of data that we had found results for. So just by looking at the visuals, you tend to find that, you know, this is your highest glare impact. As you start adding the horizontal grids and the vertical grids, you start seeing an element that's lightening up and not necessarily impacting the space in a negative way. And obviously, depending on where you put your patient bed, you would find that, you know, round here or round here would be, and this is the front of the facade, would be the most ideal space to place the patient beds. Again, like I said, for the north and the south side, we had to test it, and we continuously found that as of the facades behaving like this and the different admin offices and room spaces, we would have to sort of treat each grid slightly differently. So as we continue. So we finalized on the final configuration, and again, took our base point. If you continue through again. Let me just scroll through all the pages. The whole point of this, when we presented to the client, was to show them that actually in everything that we have done, it's been very informed. We're not just making these numbers up. We're not just prescribing to you a facade scheme that doesn't necessarily work. Stop here. So as you then begin to see the exploded axo, this is your finished, your first interior grid. You have your thicker sections, you have your thinner panels, and then you had the shading. And through all the research that I've showed you guys previously, it showed us that this would be the most adequate way of treating it. And then in our carvings and the designs that we would put on, we'd either have it on a double panel or a single panel, and the palette would also be informed by what the interior team designed. If you go through. This was our first initial sort of renders as to what that could look like for the final views. And if you keep going through. So I don't know whether you noticed if you go up again. This is the thicker side, so this is the more southern facing. And then the other one is the easterly facing. So you can see that although it's the same design, the thicknesses of the facades are different, which sometimes you don't necessarily want to deviate too far from the initial scheme of your walls, but you do need to take these into consideration, and actually you find that it starts giving more character to the building, and it says more about the way you have detailed and researched your scheme. So again, the northern facade, like I explained in the renders, you have your thinner grids, you have your thinner fins, and you have slightly less variation on the panels. Keep scrolling. Now, in terms of the decoration and ornamentation, for one of the buildings, it was to take, the lily and start abstracting it, whereby part of their passion for this medical city was that in the pharaonic times, Egypt was the place where everyone went for knowledge and everyone went for medicine, and they wanted to make sure that they are creating a medical city that not only takes into consideration of the historical culture of the community, but also says, because we did this in the past, we are going to be at the leading edge of medicine in the world. And therefore, they wanted, like the pharaonic carvings and architectural pieces, they wanted that reiterated back into their facades with a modern flair. So these were our zoom-ins for the abstraction, and we basically I personally designed the carvings for these buildings and worked with someone to sort of take it as an algorithm and script it, which would then take us through a process of production. Now, the thing is, in the UK, it's quite easy to make or think of anything you want and you find someone to do it. But something that we wanted to take into consideration was, even if we design in this way and we design to a high technical level, how do we go about implementing it and supporting the local team to actually be able to do this? So I think we concluded on a CNC way of, which CNC is basically when you take the slab and you literally carve through it with a laser cutting machine. And then we also looked at ways of creating this retardation effect, which would be by adding acid onto the GRC or the granite or whatever it is, and it would eat away at the bits that you want, and the bits that you wanted to keep, you would have. And we translated all this information to the client. If you scroll through, and this was the Doctors Plaza in the end with. This is the BUC. Obviously, we basically did it for every single building. So although every single building is slightly different, they all carry the same strategy. And the clients were very impressed and they were happy, and they presented it at the, I think, Dubai Medical Expo. We're currently waiting for phase 2, which will take us into this type of design all over again. And yeah, I mean, if I scroll through the other pages, you'd see the same iteration for every building. I don't necessarily want to bore you guys, but I just thought I'd show you what we did. Thank you.